Today's lesson is on net ionic equations. There's a lot of moving parts in here, and there's a lot of things you've already learned about this, and we just need to put it all together. So you have an example in your workbook. I'm going to do that with you. It's a little different from the way they do it in the book. I think my way's easier, but you can see both ways. I also have a help video, and so there are lots of ways that you can get more help on this. So net ionic equations are basically about reactions in water. So they are aqueous. They are double replacement reactions. They are ionic. Okay, and we need to use our solubility rule. So basically, these compounds are ionic compounds that are going to break apart in water. They're going to rearrange, and they should form a solid precipitate. If they don't, there's no reaction. Remember doing that when we did our reaction types. So the first thing to know is this is our molecular or our full equation. And what we need to know is we need to know all the ions that breaks up when we put them in water. This is aqueous, it will break up into ions. That's aqueous, it will break up into ions. Aqueous, But this is a solid, so it's not going to dissolve, it's not going to break up into ions, and it's just going to form this solid lump on the bottom, okay, when it all just settles down. So, our first thing is ammonium sulfide. So what happens when I put that in water? Well, I have an ammonium, and there's two of them, okay, boop boop, and a sulfur. So if I have two ammoniums and one sulfide ion, they're going to break up into their ions just that way. NH4 plus, NH4 plus, and a sulfide minus 2. Okay, why minus 2? Because that's plus 2. And so that's plus 1, and there's 2 of them, so that's minus 2. So you might need your polyatomic ions out, and you definitely need your solubility rules out for this. Okay, so now let's get our next little cup of water and see what happens when I put cadmium nitrate in there. Well, we have a cadmium plus 2. I uncrisscrossed that. That's how I got plus 2, or nitrate is a minus 1, and there's 2 of them, so it's minus 2, so that has to be plus 2. Okay, and then we have 2 nitrates, NO3 minus 1, NO3 minus 1. Okay, so we're just breaking them apart in water just like we've already done. So let's keep going. Here, remember, it's easy to see if I bracket them off. Okay, so let's just make sure. Ammonium and nitrate. Okay, now there's 2 of them, and remember, this distributes. So I have 2 NH4s, 2 ammoniums, plus 1, NH4 plus 1, and I have 2 nitrate ions, NO3 minus, NO3 minus. Okay, because there's 2 ammonium nitrates, so they break up into that. And then what's this guy going to do? He's not aqueous, so he's going to form this lump of solid on the bottom, and he's not going to break up into ions at all, okay, because he's not aqueous. So our complete ionic equation is this whole thing written into the ions they would break apart into. So this was just an easy way to visualize it. But what did this break up into? 2 ammoniums, 2 NH4 pluses plus a sulfide ion, S minus 2. So we're writing the complete ionic equations, all the ions that happen. Okay, and then our cadmium broke up into our cadmium nitrate broke up into 1 cadmium ion plus 2 nitrate ions. Okay, and then we are going to make ammonium nitrate, and there's 2 of those, so they broke up into 2 ammoniums plus 2 nitrates. Okay, and these guys are all aqueous. Yes, here's the tedious, super fun part of this. Not. Okay, and that's important because if they weren't aqueous, they wouldn't have broke up into ions, which is what we're going to see right here. Our cadmium sulfide is a solid. It didn't break up into ions, so I write it just like that. And that's our complete ionic equation. So hopefully when you saw when I put each one into water, what they'd break up into, that's exactly what we're writing here. But you don't have to do that. There's 2 ammoniums, there's 1 sulfide. They all match up, okay? So now, the net ionic equation, some people are going to go through the spectator ions first. I find it this way easier, and here's where I differ. What is our precipitate? What was formed here? First of all, was there a reaction? If they were all aqueous, they were all still floating in solution, there would be no reaction, but I have this cadmium sulfide, which is our precipitate. Okay, remember PPT is for precipitate. Okay? So if that's my precipitate, that is the product that was formed. And what made this product? Well, our cadmium made it and our sulfide made it. Okay? So our net ionic equation is only the things that participated in the reaction. Notice ammonium, we have 2 ammonium ions in solution and they're still floating in solution. They did nothing. They did not participate. So we call these guys spectator ions. If you're watching a football game and you don't play on the field, you don't participate in the game, you're a spectator. These guys are not participating in this game. They're still floating. I still have 2 nitrate ions before and 2 nitrate ions after. They're identical, and you can see that on either side they're the same, but here this guy participated. This is a sulfide ion, and when I'm done, it's in a compound. It changed. That's our reaction. So you can circle your solid and figure out what made it, and we can write our net ionic equation, which is S aqueous plus cadmium aqueous is going to give me cadmium sulfide solid. That's our net ionic equation. So a lot of people cancel these things out first because they're identical on both sides, and then they see what changes. I think it's easier to circle your solid and see what made it, and that's what we write right here for our net ionics. So then what are our spectator ions? Well, those are the guys that did not change. They did not react. They are just still floating in the liquid, and these are the guys that I canceled out. So our spectator ions are NH, there's 2 of them, NH4 plus, and they're aqueous, and 2 NO3 minus ions. Okay, so that is how we do our net ionic equation. So lots of pieces here. But you know how to do all this, okay? So trust yourself. Circle the solid, figure out what made it. That's your net ionic.